Very good morning, students. And for this today's session, I am going to solve a problem from the simple contact friction. In the previous video lecturing, we have solved a problem from simple contact friction with the horizontal plane, right? So as far as this problem is concerned, this plane is inclined with certain angle. Let me just read out the question first to make you to understand, and the what are the inputs being given, that means given data, and how much data which we can extract from the given question, and what to find, right? Determine the minimum force required to prevent the 100 Newton body from sliding down the plane. Take mu equal to 0.2. Right. So the given data, weight of the object has been given as 100 Newton. Mu equal to 0.2. Right. What to find? To find force required to prevent the body, that is force, which is nothing but P mentioned in the given drawing. Solution. So where the body is, that is the object is moving, we just read out carefully. Force required to prevent the body from sliding down the plane. That means this particular object is sliding down. Now, yes, minimum force is required to prevent it. That means naturally the tendency of motion is downwards. Let me just draw the FBD, free body diagram. So this is at an angle of 30 degree. This is the object and this is the P. As you know, the weight always acts vertically downwards. The magnitude is 100 Newton. Right. And what I am going to consider here is, so I am going to redraw the FBD for better understanding. What I am going to do here, instead of making all the other the reaction, friction force and the minimum force required at an incline of 30 degree, I am going to consider this weight with 30 degree, rest everything at horizontal, that is at 0 degree. Right. When the weight acts vertically downwards, this is 90 degree. This is perpendicular. Then what about this angle? See, total internal angle of triangle is 180, right? So 180 minus 90 minus 30, which equals to 60 degree. Therefore, this is 60 degree. A free body diagram in detail I am just drawing here. So this is the body and this is the weight which is acting vertically downwards. I am going to consider this as x-axis and perpendicular to x-axis as y-axis. This is the P, there is a minimum pressure, force required to prevent the body which is sliding down from the plane. So this is P. This is 30 degree. If this is 60 degree, naturally this will also 60 degree. Am I right? So W, how much magnitude? This is 100 Newton. 100 Newton. So I am going to consider the horizontal, that is a vertical component, which is 100 sine 60 degree, and the horizontal component as 100 cos 60. Correct. And when this particular object is moving downwards, the frictional force will act opposite of the moment or the motion. So this is F. And the reaction will be always perpendicular to the object, the surface of the object. So this is N. So I just want to make it very simple. As being the first problem with inclined plane, so that's the reason I just drawing in detail. So this is x-axis, this is y-axis, this is 100 sine 60, this is N, and this is 100 cos 60, and this is the P, that is the force. This is F. Is anything missed out? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Correct? Yeah. Let's consider the equilibrium condition. Applying equilibrium condition. Summation H is equal to 0 and summation V equal to 0. Summation H is equal to 0. That means going to resolve all the horizontal forces, whether it is positive x direction or negative x direction. 0 equal to, this is this P, that is a force which is acting in the positive x direction. So P, and F is also acting in the positive x direction. So F, and this 100 cos 60 which is acting towards negative x axis, so which carries negative symbol. So 100 cos 60. So F is equal to minus P plus 100 cos 60. So this can be rewritten as F is equal to 100 cos 60 minus P. Equation number 1. So now let's resolve the vertical forces. Summation V is equal to 0. 0 equal to vertical forces. How many vertical forces are there? So this weight which is acting vertically downwards, which carries negative symbol. So 100 sine 60 this normal reaction acting vertically upwards, which carries the positive symbol. So N. So therefore, N equal to 100 sine 60. That is equal to 100 into sine 60, which works out 86.6. What is the unit? It is given in Newton. So N is equal to 86.6 Newton. Right. So you can now, as you know, F is equal to mu N. Mu is already given here. So mu is equal to 0.2 into 86.6. That is equal to 0.2 into 86.6. It works out 17.32 Newton. Apply this 17.32 on equation number 1. So 17.32 equal to 100 into cos 60, which is 50, minus P. Therefore, P equal to 50 minus 17.32. P equal to 50 minus 17.32, which works out 32.68 Newton. So the minimum force required to prevent the object sliding down from the plane is 32.68. We have found the value of the force, right? I'll come up with few more, that means different type of problems in my coming video lecturing. Till now, bye bye, thank you.